Okay, let's start. Let's try to understand the secondary index in Cassandra because this is the most misused concept in Cassandra. Uh, See the reason, right? If you are from traditional RDBMS, creating index is very common practice. Let's say you hit with some performance issue. What you do is you tend to create index, so which can resolve that issue quickly. Now, in Cassandra, you have secondary indexes. Okay, you can create indexes on the table, but in Cassandra, secondary indexes are there to give you convenience, not performance. Okay, you need to keep that point. Unlike RDBMS, in Cassandra, secondary indexes will give you only convenience, not performance. Okay, we'll see how that works. So the agenda is we'll try to understand what is query first approach in Cassandra, and we also see what is allo filtering, how to create secondary index, and how Cassandra stores this secondary index, which is very important. And we also try to understand distributed index and local index. What is the difference between these two? And we'll see what is the write path and read path of secondary index. And we also see what are the best use cases to use secondary index. What are the worst anti patterns? And we also see what are the problems and limitations of secondary indexes. And we also try to discuss one more type of secondary index, which is SASE. Little bit about me. My full name is Anil Mithana. I'm passionate about Cassandra database administration, and I'm a certified Cassandra admin and certified Cassandra developer. You can find me on the LinkedIn link. So let's start. What is query first approach? So in Cassandra, before you start thinking about data model, you need to understand what is your application workflow. So again, unlike RDBMS, right? In RDBMS, what you do is you create a data model first, then you think about application workflow, what all queries you want to run on the tables. But in Cassandra, it is reverse. You need to know your queries first. You need to know your application workflow first. Based on that, you create your data model and you create your tables. So let's see, on the left side, I want to get the all the ratings left for a movie. So that is what my requirement. I want to know at any given point of time, this is what my requirement from my table. I'll ask you, give me ratings for a particular movie. To do that, you need to create a table this way. You need to have a primary key configured in this way, where title is your partition key, because based on title only you will look up later, right? And here email is a clustering column which gives you uniqueness to your primary key, and also it keeps the rows within the partition in a ascending order by default, right? So pay attention to the title column, which is partition key. When you create a table like this and when you insert data into the table, this query is very much possible. And let's try to query it. I already loaded the data. I created the table with the same create table statement, and I inserted the data also. Now, what I want to query, what is client requirement? At any given point of time, he'll ask me what and all ratings given for a Avatar movie, who and all watched and what and all ratings it got. Okay. Now, to get that information, what I do is I'll write a select query, select start from ratings by movie, where title is equal to let's see, Avatar. Now when I query that information, it's a single disk read. What I mean by single disk read, how Cassandra stores this data when you create a table like this by making title as a partition key. So right here, title is a primary index. Basically, you call it as a primary index also, and partition key. Now your primary index, right, is a distributed index, meaning what happens here is when you make title as a partition key, which is your primary index, now Cassandra will keep this entire avatar data in one single place, in one single node. So your table data will be distributed in terms of partitions. So now here I'll call my table as a collection of partitions. Instead of calling collection of rows, I'll call it as a collection of partitions. Right? See, my partition is having rows ultimately. Now, what Cassandra do here is it will keep this partition in one node, this partition in one node, this partition in one node. That's way, that way you can have entire information about Avatar movie in one single place, isn't it? And whenever you query, it's a single discrete because you have to go and grab it from one single node because your partition data will never get shared with other nodes. Here I have three nodes here. Okay. Now, whenever you ask for interstellar information, it will go and grab it from one single node. It's a single discrete, very powerful, right? Now, let's say you want to get the rows, you want to know the ratings left by a user. So that is what my query requirement. And at any given point of time, I'll ask this: give me what and all ratings given by a user for what are all movies he watched. Okay, if that is what your requirement, this particular table will not work for that particular query. Okay, so you have to create one more table. You need to duplicate the data by making email as a partition key. Here, title is doing a clustering column. It is giving you uniqueness and keeping it in an order within the partition. Now, you need to duplicate the data. If you have a different select query where you want to keep a different column in your where condition, right? Now, when you create this table, and let's see how data will get created. I already created that ratings by user table, and I already loaded some data. Same data, whatever you have it in ratings by movie, I loaded here. But the way Cassandra stores the data is different. Now, because I made email as my partition key, now what happens? All the ratings given by RAM will you call it as a one single partition, and it will get stored in a single node. Same with Sharma. See, every time Richa watches one more movie, that data will come and sit in this partition, and that partition will get sit in one single node. Okay, so your table data is getting distributed in terms of partitions, right? Now, if let's see, if I want to query all the ratings given by a user RAM, it's a single discrete because it has to go and grab it from one single node. All good, right? I hope you got to know what is query first approach by this time. Let's see what else we have now. Now, allow filtering. What is allow filtering? Now, let's go back to your ratings by movie table. Now, my business requirements got changed. When I started, I told you at any given time, I'll ask you only give me information, look up by only title. But now I want to know what are all ratings, like how, give me all the rows where rating is equal to 8. Okay, clear this. Now, what I'm asking now today is give me all the rows where rating is equal to 8. Now, is this possible? No. Till now, whatever we discussed, I can only look up by title, right? So I can only look up by title on this table. I cannot look up by rating, isn't it? Yeah, because in Cassandra, you cannot query on non-primary columns, correct? Okay, let's fire this query. Now, this query will fail because you cannot look up by rating. Now, if you read that query, I mean that output, what it is telling you is cannot execute this query as it might involve data filtering and thus may have unpredictable performance, right? If you want to execute this query despite of performance unpredictability, use allow filtering. Now, what Cassandra suggesting me is, it is telling me use allow filtering. Now let's do that. Now, when I say this, it worked. So allow filtering is working well. I got to know all the ratings where it is 8, right? So can I use allow filtering now? The answer is a very big no. You should never ever 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 use allow filtering on your select queries, because what just happened here is, when you run allow filtering, Cassandra retrieves all the rows from that table and apply filters and returns the matching rows. So let's say you have 1 million records in your table, and out of 1 million, let's say 100 rows are having rating 8. Now, when you query this using allow filtering, basically what just happened is it retrieves all the 1 million rows and it applies the allow filtering, and I mean it will apply the filters and it will give you those matching 100 records. Okay. Now, which is completely bad to do in terms of Cassandra. Okay, so that's the reason you should never use allow filtering. Basically, when you do allow filtering in terms of RDBMS, basically you are doing a full table scan. Here in Cassandra, it's a full cluster level scan. So it might bring down your node also if you do allow filtering, if the table is too huge. Okay, so try to avoid allow filtering. Then how can I get that rows where rating is equal to 8? So there comes your secondary index. Okay, so we were talking about secondary index, right? Like, what I do is I'll create a secondary index on column rating for this particular table. Now, when you have a secondary index on a rating column, basically you can now run that query without allow filtering. Now see what happened. You got the result now without allow filtering. So if the index works this well, why not go ahead and create indexes on columns whenever wherever it is required? Why do we need to duplicate the data, or why we need to create one more table to satisfy that query requirement, right? So let's go back to our very second slide. Here, initially I was looking up by title. When I want to look up by email, because I cannot do it here, I created a duplicate table. Now you might ask me, why can't you create a secondary index on email column so that you can look up by email column also, which I just did on rating column, right? So now this is the place where things will become little complicated to understand. So pay attention. Now, when I wanted to look up by rating, now I have two options. One is either go and create a secondary index, or create one more duplicate table by keeping rating as a partition key. Two things, right? Now, you need to understand how Cassandra stores the secondary index data, and how our regular we know already how our regular table data will get stored, right? So we need to understand how secondary index data will get stored. So first thing first, what I do is I'll create a duplicate table for our understanding so that I can compare with the secondary index table. Okay. Now, before even doing that, what I wanted to tell you is, when you create a secondary index, let's say you just create a secondary index on a rating column, Cassandra creates a hidden table. It looks like this. So it keeps the rating as a partition key, and it will keep entire primary key of your base table as a part of the primary key here, and it creates this hidden table and it will manage it internally. Okay. Now when you create a secondary index, you got a hidden table, right? We need to know how this hidden table stores the data. Correct. Now, before that, now what we do is, like, let's create one duplicate table by making rating as a partition key, and we'll try to see how our regular data will get stored before we try to understand secondary index table data. Now, what I was telling you is, like, I'm asking you, instead of creating a secondary index on rating column, try to duplicate the table by making rating as a partition key and see how data is getting distributed Then go back and see the secondary index hidden table. Okay. Now I already created this table and I loaded this same data, exactly what we have in other tables. And let's see how it stores. See what happened here when you make rating as a partition key. What it does here is, now your table data will get distributed in terms of partition. So whoever gives you rating 8 will be will be in a single partition, isn't it? Now let's say someone watched a movie and he given rating, that row will come and sit in this particular partition. Now if I want to query who are all given rating 8, what I need to do is select start from ratings by rating, where rating is equal to 8. Now we already know when this is a single discrete, right? That's what you get it from a base table, isn't it? Now you ran the same query here also, but here rating is a secondary index. Now pay attention. Now we know how base table stores the data. It stores in a, like, all the ratings given to all the ratings of 8 will be in a one place, all the ratings of 9 will be in one place, right? That's how your duplicate table stores the data. So let's switch to secondary index. Now how secondary index stores the data, very important. Now let's, yeah, this is your regular table, this is your hidden secondary index table. Now this is what your it looks like. Now here, when you create index, your index data will be collocated with the source data on the same node. What I mean is, this is what your data on the node 1. And for Avatar movie, 3 people given rating 8, 3 people given rating 9, and 3 people given 7. So only that data will be collocated in the same node in that hidden table, right? So the index data of this partition will be stored in this node, right? So basically, all the ratings of 8 are are not in one place, but that is how it is in the original base table, right? Original duplicate table where you create a ratings by rating table. But your secondary index hidden table will not show that way. It will not distribute. Instead, it keeps the index data local to that node. So very important. Now if you run that query, select start from ratings by movie, where rating is equal to 8, to give you that output, what just happened here is, because it is not in one single place and it doesn't know where it is, it has to scan every single node. So it scans this node, it will come to know, okay, there are 3 rows. Here also it will come to know. So here also there are data. So it scans the, so every node will get involved when you query that, when you query based on secondary index. When you say that the select start from ratings by movie, where rating is equal to 8, when you said that, what happened is all the nodes within the cluster are involved in that query. You have 1,000 nodes will get involved in that query. So which is completely bad, isn't it? Secondary index, when you use secondary index, when you query by secondary index, you are involving every single node. But when you duplicate the same thing, you are involving only one single node here, here, right? When you have a ratings by rating, where rating is your primary index is a distributed index. So whenever you query, only one single node will be involved. And when you create a secondary index will create a hidden table. Whenever you run this query, basically it's a whole, every single node in the cluster will involve. Now here I'll tell you, it also depends on your replication factor also. So let's say you have 100 nodes with replication factor is equal to 3. In that case, you need to hit at least 33 nodes now, because your replication factor is equal to 3. If your replication factor is equal to 1, you need to hit all 1000 nodes, I mean all 100 nodes. Okay, so it also depends on your replication factor, but still you have to hit lots of nodes to give you this output. So you got to know like what is happening with secondary index. Secondary index is a local index basically. So your index data will be co-located with the source data on the same node. Because of this reason, whenever you query, all the nodes will get involved. Now you might ask me why secondary index data is getting stored in this way. Why cannot it keep all the ratings 8 belongs to in one single place, right? Why it is keeping only local data? Why can't it go ahead and distribute rating 8 into one place, rating 9 into one node, rating 7 into one node? Why can't it do that? Because if Cassandra behaves in that way, you will end up with wide partitions. What I mean, let's see, you have like in your table you have 2 lakh records. Okay, out of 2 lakh records, imagine 90% of the rows are having rating is equal to 8. No, if you think in that way, right, like, why can't it is keeping all the 8 related data in one node? What happens? 95% of the data will be in one single node. So this node will have a wide partition, and it will have additional extra load also in terms of data. So to avoid that, to avoid the wide partitions, what it does is it will keep the data to local. And one more thing, second point is updating index also. So you this way when you have a local index, it is easy to update your index data whenever you make changes, whether it's update, insert, or whatever you're doing. Updating index data will be very much easy when you have a local index data, right? When your index is distributed, then it is tough because it doesn't know where to go and update the data, right? So two things why it is keeping data local, index data local. Okay, two things. These are the two technical reasons why Cassandra will not distribute your secondary index data. One is to reduce index update latency. One more to avoid arbitrary wide partitions. Okay. Now we already know what is distributed index and local index. So your partition key is a distributed index, which is in your base table. Your secondary index is what you call it as a local index. Now let's see how Cassandra write index data, how it reads the data, right? Now writing, when what happens, you have a whenever you create a secondary index, you have an index mem table and you have a base mem table. Basically, whenever you flush, that index mem table and base mem table will go into the same SS table. Again, it's not, it is, there is no guarantee also in this behavior. Once the data is written into the SS table, your index data will have a different life cycle, whether it's a compaction, all that stuff. It will not go with the what you have for your base table data. Okay, it follows a different life cycle. Now, read part we already understood. Whenever you are reading by secondary index, it is not quite straightforward, isn't it? What it does is first it reads the index table to retrieve the primary key of all the matching rows. Then it reads the original table. Let me see, show you this, right? See, whenever you are saying rating is equal to 8, it reads the index. It does one lookup on your index data, and it will pick up all the primary key information, and it will go and grab that information again. So two discretes. One, it will look up into the index and it will get the primary keys, and it will go and get that information from your base table, right? So again, secondary index will have a read latency because it is doing because it is not straightforward, right? So again, there are like we are loaded with so many um, reasons to not use secondary index, because clearly secondary index is not there to give you performance, isn't it? Then you might ask me, then what is the point of having secondary index in Cassandra, right? So if they are there in this in the product, meaning they must have some reason to be there. Now what would be the reason, right? Now The best case is, I'll tell you what is the best use case. See, so you, instead of asking, give me all the rows for where rating is equal to 8, which will do a entire cluster scan, right? Instead of asking that, what you ask is, give me ratings, give me all the rows where rating is equal to 8 for a particular movie, right? So, see, if I say select star from ratings ratings by movie where rating is equal to 8. See, if you stop your query at this moment, it's an expensive query. But what if I keep title is equal to avatar? Now, this is what you should use. This is what a real transactional query, right? Now, when you run this query, what happens is it just go and grab it from one single node, isn't it? So you are limiting your query to a single node, and it is very fast way of getting the output, isn't it? So if you stop here, it's a entire all the nodes will get involved. When you stop, when you run this query, ratings, now you got this information by querying only one single node, isn't it? Right, because you kept partition key also in your select query, right? Now that is what you need to do. See, you have to limit your node hit. So one way, right, this is one way which will limit the select query to one single node, or you can even say limit is equal to, let's see, 3. Now what you are telling, instead of scanning every single node, whenever you reach whenever you get 3, right, you stop looking and give me that output, right? So this way, let's say you have 100 nodes, and the moment it reaches that output, it will, let's say, this query hit the 3 nodes to give you that output. So that's it, right? You got the output by hitting only 3 nodes. So use limit or use partition key along with the secondary index. So that is the best way of using secondary index. That's what I was telling. Secondary indexes are there to give you convenience, not performance, right? Now, what are the best use cases? Obviously, you have to restrict the query to a single server. How you do it? By introducing partition key along with the secondary index, and also limiting the nodes to a lesser number. Maybe you can use limit to do that. Oh, and one more thing, secondary indexes are very helpful in analytics workload, like when you are using Spark Cassandra connector, where your SLA doesn't measured in terms of milliseconds. So these are some best use cases to, if you want to use secondary index. Now, what are the anti patterns, right? And worst anti patterns, you should never create a secondary index on a very low cardinality column. For example, gender, right? No, because you have only two options. I mean, very less options, right? Like a male or female. So you will end up with a wide partitions when you have secondary index on that gender column. And you should avoid creating secondary index on high cardinality column also. For example, best example would be your user email, because you get to have lots of distinct values for your index data, isn't it? So whenever you query, you might get that output by hitting one single node, or it has to hit every single node. Maybe you end up with 0 rows, right? So you have to avoid these two options. Again, obviously, if you are doing lots of updates on the index column, you shouldn't create index on that column at all, right? You have to avoid index a column where you update very frequently. Now, what are the problems and limitations with secondary index? See, again, it's a shocking news. If you are from RDBMS, you cannot, you can query only using equality parameter. You mean equality on your secondary index column. You cannot put range queries, inequalities on your where condition on the secondary index. Okay, and some the one more the problem. Second point is actually a problem. What it telling you is because you will not compact your secondary index data and the base table data together because it will not follow same steps, right? It has a different life cycle. You might end up with uh, like that's what, right? Independently compacting ss table and indexes means the location of the data and index information are completely decoupled. So maybe you index data is pointing your ss tables, but that ss tables got compacted, then obviously it will not point that location on the disk, right, which was it earlier it is pointing. So it's a problem basically with secondary index. Now basically, now what is SASE index? So in general there are two types of secondary indexes in Cassandra. One is what you witnessed till now, native secondary index, right, where the limitation is you can only use equality uh, operator. Cassandra will also give you one more kind of a secondary index. You call it as a SS table, I mean SASE index, which is SS table attached secondary index. When you have this, basically you can actually do inequalities, right? Everything is similar, but it will give you more flexibility. You can do range queries. Again, SASE is experimental. You shouldn't use it in production Cassandra cluster. Now, let's try to do some practicals on SASE index. Now what I do is on the same table, let's create SASE index. So I'm creating a SASE index on ratings column and we'll try to do inequalities queries, right? So I created a SASE index. It is giving you a warning. SASE indexes are experimental or not recommended for production use, right? Make a note of it. Now, once I have it, obviously you need to use partition key along with the secondary index. That's how you should use your secondary index. And you can use now, you can use inequalities also, right? Previously you can only query rating is equal to 8. Now you can ask less than or greater than equal to operators also. Now what is expensive is querying directly on secondary index, isn't it? Basically it will involve every single node. So those are some inequalities, and you can also create let's create a secondary index, SAS index on user location, and we'll try to use like parameter to query the data, right? So what would be the real-time transaction query? You have to you keep your partition key. That's how you should use secondary index, and you can get this, right? And what would be the expensive? Obviously, without putting partition key, right? Now you can use limit, let's say limit 5, right, so that you can avoid hitting number of nodes. Now now you will think like, okay, secondary indexes are okay, SASE is much better compared to secondary index, right? Again, that you need to understand again, SASE index, basically SASE attaches to each SS table. And what I was trying to do, I understand you here is, when you create a second SASE index, what it does is it creates in one SS table for you, for your for your index data. So to understand that point, what I do is like I'll try to say no to flush. So secondary index is a hidden table, right? it never have a physical representation, but your SASE will have a physical representation, right? Okay, we'll see what is that. So what I do is I'll go to my data location. That is my cluster T, then ls-ltr, because I dropped my tables a lot of time, so I see lots of folders. In Cassandra, when you drop a table, you have to go and clean up the physical location also. Now, if you see here, SASE attached to each SS table its immutable index file, and also attaches an index to each mem table. So what happens here is every time you compact, during the compaction, the SASE index file also compacted together to create a new index files. Okay. So if you decided to use a SASE in production, keep in mind that SASE impact your compaction, repair, and write throughput, because it is expected, because SASE index file follows SS table life cycle, right? So secondary index doesn't have a hidden it has hidden file, but here you have to deal with the SS tables also. So again, that is also a consideration. You have to deal with the compaction, right? Throughput, latencies, every single bit. Whatever SS table will go through, your SASE immutable files also will go through. Okay, so two things you keep in mind, because they are still experimental only. So that's it. We come to an end. I hope you understood out of this something. What I wanted to convey is secondary indexes are there to give you convenience, but not performance. Okay. And if you want to use them, make sure you keep a primary, like you make sure you keep a partition key also from the base table, or else try to use limit. I mean, the point is you need to limit the query hitting less number of nodes, and you should avoid creating secondary index on very high coordinating columns and very low coordinating columns. Okay. And very general recommendation is to have at most only one secondary index per table, and most of the time you should avoid a secondary index completely creating them. Okay. Yeah, with that, I would like to thank you. If you are still here and listening to the whole piece, stay home, stay safe. Thank you, and please subscribe and like this video if you want me to do more number of videos on Cassandra database administration. Thank you.